Okay, here's part two of the screencast on life in the universe. Let's move beyond the solar system. What might be out there? All right, before we get to that, however, it turns out that humanity has already sent several messages to the stars. We've done this a couple of different ways. We've done this, first of all, with our space probes. So back in the early 1970s, our first reconnaissance of the solar system occurred with two missions called Pioneers 10 and 11. These two missions conducted flybys of Jupiter and Saturn. The follow-up missions to the Pioneers, which occurred about 5 years later, were the two Voyager missions, Voyagers 1 and 2. Voyager 1 flew by Jupiter and Saturn. Voyager 2 flew by Jupiter and Saturn, and also Uranus and Neptune. At any rate, however, those four space probes were flyby missions. They are on their way to the stars. They are never coming back. All four are actually now in interstellar space. It will take tens of thousands of years for each of these four space probes to pass by the nearby stars. However, attached to each of these space probes is a message from humanity to whoever it is that's out there that may actually happen across these space probes and find them one day. So, for example, with the Pioneer missions, attached to the side of the Pioneer missions is the following plaque. This plaque shows the relative size of human beings relative to the space probe itself. And then this information down here depicts the solar system where the Pioneer mission originated, for example, the third planet here in our solar system, Earth. Okay, this very famous diagram that you may have seen before, this diagram right here is actually a map. It's a map of the location of the sun relative to pulsars within the Milky Way galaxy. So a technological civilization that happens across the Pioneer missions will understand how to read this map and then figure out where we are located. Okay, similar messages are attached to the Voyager missions as well, but they're a little bit more detailed. The Voyager missions contain on their sides this vinyl record. So this vinyl record right here is kind of like a precursor to CDs. It contains audio and video files of people speaking, pictures of the Earth, and so on and so forth. And then the vinyl record itself is encased in this gold case here, which is then attached to the side of the Voyager space probe. And then there's once again the pulsar map and so forth, like on the Pioneer missions. There's information right here about how to actually play the record. This is assuming that an alien technological civilization more advanced than our own has absolutely no idea to play vinyl records. So the information on how to do so is actually contained here on this gold case. Once again, each of these four spacecraft, the two Pioneers and Voyagers, will take tens of thousands of years to pass by the nearby stars. Okay, and then the other way in which we have sent messages out to the stars is just from radio waves. Whenever we use radio waves to communicate or through our electrical circuits and so on and so forth, well, that energy just leaks off of the Earth and then out into the universe. It's of an extremely low intensity, so you would have to have an awfully big radio telescope in order to be able to pick up those radio waves. But those radio waves that we are artificially generating are just leaking out into the universe. Perhaps an easy way to determine whether or not there are other civilizations out there is to listen for their radio waves. So the first time that this was ever done as a project, it was called Project Ozma, was done in the early 1960s, and Project Ozma later evolved into SETI, the Search for Extraterrestrial Intelligence. The astronomer who was involved with Project Ozma and then later what evolved into SETI is this gentleman right here, Frank Drake. He is currently a professor emeritus of astronomy at UC Santa Cruz, and he is the person most directly responsible for setting up SETI, the Search for Extraterrestrial Intelligence. Drake tries to quantify the problem of actually how many civilizations might be out there in the Milky Way galaxy alone, and in order to do so, he develops an equation, what's referred to as the Drake equation. The Drake equation is basically a string of probabilities all being multiplied together to give you a number of active radio wave communicative extraterrestrial civilizations in the Milky Way galaxy. How many civilizations might be out there? Well, the number of civilizations that might be out there is basically quantified by multiplying together these various probabilities. Some of these probabilities come from astronomical data. For example, the first term, the average rate of star formation in the Milky Way. The Milky Way galaxy forms stars at a rate of about 1 solar mass per year. And then the number that we also have a pretty good handle on is the fraction of those stars with planets. Over the course of the last couple of decades, we have literally discovered thousands of planets orbiting nearby stars. Probably the total number of planets in the Milky Way galaxy alone numbers in the quadrillions. And then we have right here the number of those planets that then potentially support life. We're starting to get a pretty good idea as to the value of this number here. It may be as many as one per star. After that, however, it gets a little bit nebulous. Then you have the next term as the fraction of those planets that develop life at some point, the fraction of those planets that develop intelligent life, the fraction of those planets that actually result in an intelligent, technologically capable civilization that is leaking radio waves out into space. Of course, these numbers here for now are all speculative. And then we get to this very important number here at the end of the expression, and this is essentially the length of time in which a civilization survives to leak out radio waves into the universe. Of course, this is of extreme importance for our own civilization. How long do civilizations actually last? We'll get to that a little bit later on. When you multiply our numbers that we have here as best guesses together, you then end up with a number of technologically capable civilizations in the Milky Way galaxy. Right now, our best guesses range from as little as 10 to maybe as many as 10,000 radio communicative civilizations in the Milky Way. Okay, now let me show you a picture here of the Arecibo Radio Observatory. This is basically one of the largest radar dishes or radio telescopes in the world. It's in Puerto Rico. The reason why I'm mentioning this is because this particular radio telescope is also capable of sending signals into space. And specifically at one time in the early 1970s, we used this telescope to generate the loudest radio signal that we have ever done. We basically screamed out into the universe in terms of radio waves as loudly as we possibly could at the time. We aimed that signal in the general direction of a star cluster called M13, which is about 10,000 light years away from the Earth. Okay, the signal itself is depicted here in this picture. Okay, this picture right here basically is in terms of binary code, and it gives out basic information about humanity. So for example, right here is a human being. Right here is a depiction of the solar system. Right here is the third planet from the sun, which of course is the Earth. This right here is a depiction of a DNA molecule. There's various mathematical information that are contained within these characters here and so on. So we basically screamed as loudly as we possibly could into the universe in the hopes that somebody out there may be able to read or pick up this signal. Okay, now what kind of civilizations may actually be out there? How do you kind of quantify that as a problem? Well, a Russian engineer named Kardashev came up with the following idea of classifying civilizations based upon their energy consumption. First of all, he describes what is called a Type 1 civilization. Type 1 civilization is basically able to harness all of the energy resources associated with their planet. And then there would presumably be a certain amount of radio waves generated by such a civilization. Our civilization, however, is not quite at this point. Carl Sagan, for example, estimated a number of years ago that the Earth is maybe about 0.7 or so on the scale in terms of being able to harness the energy output and energy resources of a single planet. And then more advanced than that, what's called a Type 2 civilization. A Type 2 civilization would be a civilization that's capable of harnessing the energy resources associated with its parent star. So what would be an example of a Type 2 civilization? Well, think of Star Trek. Imagine in Star Trek that technologically advanced society is able to harness the energy resources of a single star. That seems reasonable based upon the fiction of Star Trek. Star Trek would be a nice example of a Type 2 civilization. And then right here is what's called a Type 3 civilization. So imagine a civilization that is so advanced that it's actually able to harness the energy resources of an entire galaxy. And then imagine how loud such a civilization would be in terms of their use of radio waves. So as you go from a Type 1 to a Type 3 civilization, presumably such a civilization would get louder and louder in terms of its radio waves, in terms of its output. All right, so what have we looked for thus far? What has actually been searched by SETI over the last few decades? Well, this graph right here depicts that. First of all, on the left-hand axis like so, is the output associated with radio waves, basically the power that would be involved in generating radio waves. And this right here is an exponentially increasing axis. And then for comparison, over here on the right-hand side would be presumably, this is all kind of based upon assumption, presumably what that output of radio waves would correspond to in terms of a type 1 or a type 2 civilization. So an Earth level civilization such as our own, just leaking radio waves out into space, basically we're not very bright, if you will, in terms of our radio output. However, when we used the Arecibo radio dish back in the early 1970s to scream as loudly as we could, this right here was basically our output on the graph. A type 2 civilization, presumably a type 2 civilization would be really loud in terms of radio waves. That would be the output over here associated with such a civilization. Okay, and then on the horizontal axis here is the distance from Earth in terms of light years. Right here is 10 to the 5th. 10 to the 5th is 100,000 light years. That's the extent of the Milky Way galaxy. Right here is 10 to the 7th. 10 to the 7th is 10 million light years. That's basically the extent of the local group of galaxies. So for example, take right here a type 2 civilization. We have thoroughly searched the universe for a type 2 civilization, something that is this bright, if you will, in terms of radio wave output, all the way past the extent of the local group of galaxies. We haven't seen any type 2 civilizations out that far, let alone type 3, for example, which is not even on this graph. However, if you're talking about civilizations that are maybe a little bit more advanced than the Earth, like a type 1 civilization or an Earth-level civilization, we've thoroughly searched out a distance, if you will, perhaps of maybe 100 light years or so. But after that, as you can see, our knowledge of the universe gets a little bit sketchy. So we've searched for very bright radio emissions out there associated with very advanced civilizations. We really haven't seen anything out to a great distance. And when it comes to civilizations that are comparable to the Earth and maybe a little bit more advanced, there's still a long way to go. Okay, lastly here for part 2, there have been a handful of interesting radio detections over the years. This is a famous example of this. It's called the wow signal. The wow signal was detected in 1977. It consisted of a very bright narrow band radio emission. A narrow band radio emission is essentially a radio emission that goes beep. That's easy to produce technologically with electrical circuits, but it's very difficult for natural processes to produce such an emission. Natural processes basically more or less produce static, something that sounds like this. It's very difficult, however, for that type of a process, a natural process, to produce a beep. So there have been a handful of beeps that have been detected over the years, but nothing that has ever been repeated. The most famous example of which is called the wow signal. However, the wow signal has since been shown to have a natural explanation. Okay, let me go ahead and pause here as part 2.